As you are well aware by now, Excel is excellent at analyzing data, either with pivot tables or with its many other tools. However, Excel isn't necessarily the best place to store data, especially large amounts of data. This is why corporate data is usually stored in relational database systems. There are many such systems. One of these is Access, which is part of Microsoft Office. Access is a desktop system, where the software itself and the databases you create with it are typically stored on your hard drive. Others, such as Microsoft SQL Server and Oracle, are server-based systems, where both the software and the databases are stored on a corporate server, and you typically need permission to gain access to them. Fortunately, all relational database systems store data in basically the same way, at least from a logical perspective, and they are all optimized to store and then retrieve data in a very efficient manner. However, these database systems aren't typically built to analyze the data. In short, they are good at storing data, and Excel is good at analyzing data. Therefore, the usual procedure is to import data from a database system into Excel for analysis. Several companion videos will provide details on how this is done. The current video will explain the underlying concepts behind relational databases. You should realize that whole semester-long courses are devoted to this topic, but the basic concepts are fairly simple to understand. Imagine that your customers place orders for various products, where each product is in some category. You want to store data on these orders. The key concept in relational databases is that you should separate the data into a number of related tables, one table for each entity. In this case, the entities will be customers, orders, products, and categories. So there will be a table for each of them. Actually, there will be a fifth table, line items, which lists the products in all orders. The reason for separating the data into tables is simple. It avoids redundancy. For example, if you keep track of the address, phone number, gender, and other attributes of a given customer, this information will be stored exactly once in a single row of the customers table. Here is a typical customers table shown in Access. Here are the other tables: the products, the product categories, the orders, and the line items. Then the tables need to be related in some way. For example, if you want to know information about a customer who placed a given order in the orders table, you need to be able to look up this information in the customers table. The relationships are accomplished with primary and foreign keys. A primary key is a unique identifier. For a customer, there could be a natural primary key like a Social Security number. However, a simple auto number primary key is often used, where customers are numbered 1, 2, 3, and so on, and the ordering has no intrinsic meaning. Actually, the auto numbering you see here starts with 1001, but this makes no difference at all. For example, Will Thompson is customer 1002. Then for all orders placed by Will Thompson, there will be a field in the orders table that lists 1002. Here is the orders table. This customer ID field lists the foreign keys. These relate the two tables. I will filter so that I see only Will Thompson's orders. And then undo that. It actually goes both ways. If you see foreign key 1009 in the orders table, you can go back to the customers table and look for the unique 1009 value of the primary key to see who placed the order. Jeffrey Davalio. Just remember that there is no information about customers in the orders table except for their foreign keys. This avoids redundancy. The relationships, as well as the tables and the fields within the tables, are best shown with a relationships diagram, as you see here. Each ID field is either a primary key field or a foreign key field. The primary and foreign keys don't have to have the same name, like customer ID, but they often do to avoid confusion. There are actually two types of relationships, many-to-one and many-to-many. In the diagram, the many is represented by the infinity sign. The relationship between customers and orders is a typical many-to-one relationship, with orders on the many side and customers on the one side. That is, each order is placed by a single customer, but each customer can place many orders. A similar many-to-one relationship holds between products and categories. The relationship between products and orders, however, is a many-to-many relationship. Each order can be for many products, and each product can be part of many orders. For this type of relationship, it is common to have a so-called linking table, in this case, the line items table. This is usually a long, skinny table. It often has only foreign key fields, in this case for order and product, although it can have other information about each line item, such as the quoted price and quantity ordered. It is a long table because it has a row for each product in each order. You often hear the term normalized. This simply means that the database has been broken into separate tables, one for each entity, to avoid redundancy. This is the form advocated by most database people because it results in efficient storage. However, to get interesting data out of the database, the tables have to be joined. For example, if you want all information about orders placed in the month of May by customer 1023 for products in category 7, all of these tables are involved, and they must be joined in some way to get the desired information. This request is called a query, which in itself is a huge topic. To understand how pivot tables can be built from relational databases, one of the ultimate goals of this course, you must not only understand the relational concepts discussed in this video, but you must also understand queries. They will be discussed in follow-up videos.